Good morning, good afternoon, everybody. Welcome for joining LRVS event with FluTech. Thank you for joining with us. We are happy and delighted to introduce Mr. Tomas Klima, the CEO of Ecol Industrial and the head of International Sales Division at Ecol SP. He was working in power generation since 2005. He is certified lubrication specialist. He will be helping us to figure out turbine engineer dilemma to clean polluted turbine oil system or build a new one. Welcome, Thomas.
Hello, everybody. I am opening my presentation. Good morning, good afternoon. I'm here. I'm glad to be here today to share with you our experiences in the oil system cleaning and flushing. Today addressed to turbine engineer with turbine engineer dilemma. Whether to clean disastrously polluted turbine oil system or build a new one. Let's go to agenda. At the first, I will say a few short words about Ecol because my colleagues were also presented. Actually, the co-author of this presentation is my colleague Wojciech Majka that was having a speech 30 minutes ago. And also other colleagues are today presenting. Then I will briefly introduce the degradation process of ester-based oil, which was in use in the turbine that I am presenting today, how we clean and how we handle it. I will say a few words about strategy, maintenance strategy, how to plan the maintenance before the overhaul, how to select the technology for the service. Then introduce in deep focus the technology of cleaning, hydrodynamic cleaning of a turbine oil system, especially here in a specific nuclear power plant where we did the service, where I have a lot of photos sharing with you, and follow up with high velocity oil flush with a very large system with oil capacity of 130,000 liters of turbine oil. At the end, a short summary and then answering your question. Ecol is a service-oriented company providing the services worldwide with the headquarters in Europe, in Poland, and with subsidiaries in Czech Republic, where I belong to as Ecol Industrial, and subsidiary also in North America as Ecol North America. The services we are providing on the market are lubrication and oil services, cleaning and flushing of oil system, condition monitoring, oil care and varnish mitigation experience. And we have our own laboratory where we analyze the oils and greases. We are authorized partner and technical partner from Lotos, Fluitec, and Greasethief. We specialize in lubrication management outsourcing, what was presenting my colleague, where we service over 24,000 pieces of machinery every day, with 400 almost people on board, and 70 engineer plus are within our company. Yearly, we are delivering 1,500 tons of lubricant. So the scope of our activities is very large. The industries we serve, you see on the right, me especially, I'm rather focused in oil and gas, power generation, and chemical industry. And now I go to the point of my presentation, because the case study I'm sharing today with you was a turbine oil system in nuclear power that was run on ester-based oil, where water is very dangerous contaminant, and the water content should be maintained very low. Otherwise, the hydrolysis is the degradation process that is as results of high water content. The hydrolysis is actually degradation or breakdown of the base oil molecules, followed with additive depletion, formations of acids, and of course followed by severe corrosion of the components inside the oil system, and especially corrosion of the pipeline. The aging products from the degradation process and rust that is polluting the oil system, which is resulting in increased wear and component degradation. So how to handle this issue is the questions that was addressed this presentation, and to evaluate the maintenance, the prepared maintenance for the overhaul or for the service, we need to figure out what is the level of contamination based on lab reports, of course, looking at the trends and history, looking at the time of lifetime of the oil, evaluating also the operational issue like temperature, vibration, water content, what is the filter exchange frequency, what was the maintenance history, and if possible, if the customer is smart, is from time to time also doing the video endoscopy of the system to have the background for the decision. Not looking only on the oil analysis reports, but also for the real state of and real condition of the oil system. If we have the information that the system is dirty, and we got the information from our customer from nuclear power that the oil is in very bad condition and the system should be cleaned, so then we are together considering with the customer what are the options, what could be done to do the service. Of course, draining the oil and putting the new oil, plus maybe cleaning the oil reservoir, is the cheap option and a good option for the financial management, but it has also a lot of disadvantages where the new oil is dissolving all the deposits and bringing the problems for the future operation. Dissolving also means running in the system and damaging the components. Chemical cleaning is the technology that I am seeing very few not very frequent. It's dangerous. It's dangerous for handling. Is also for the environment, and it has also a big disadvantage that it's contaminating the new oil after the service, because the chemical residues remains in the system and contaminated the new oil. Solubility enhancers is an option today also used. We have our own experiences. It has its limitation, it has its advantages. Limitation here for this case study I bring for you was the high amount of degradation products plus really massive corrosion in the system, and also the size of the system. Or there is technology that I'm going to present to you. This is hydroblasting, hydrojetting, and it is applied, and I would recommend always to apply it when a severely contaminated system is in place. I mean, a lot of varnish inside or aging products, massive corrosion, or if we have some component failure like bearing, says bearing is massive pollution for the system, which is very hard to flush out. And when oil is exchanged, it is underlined because, as I mentioned before, this is the time if we are changing just the oil with new additive package, which is very well and which is very well dissolving the old deposits and making problems during the operation. Usually the filter exchange frequency is very high, and the component failure or the availability of the unit is very affected. When new system is installed, it's also the answer to the title, whether to clean or install new. When installing new, it's always you have new pipes, but they are not clean. They are full of debris from cutting and from grinding, and you need to anyway to flush it out afterwards and clean it before going into service. So it's better to clean it. Hydrodynamic cleaning of oil system is the proven technology, which I will show you later on. And also highlighting the specific in nuclear power, because we are working in nuclear power since 2008, and we know the environment very good. Safety first is the main approach in the nuclear power. Running on full load with high availability is the general goal, because when it's built, the costs, the operational costs are much lower comparing to conventional power plants. Oil system, due to the also size of the turbo generators, the oil systems are of large volumes. Me personally, I'm experienced with turbines here in Czech Republic with volume of 100 tons of oil. This case study, I was also being present during servicing. It has 130 cubics of oil in service, which is really huge. The turbine is 50 meters long. The size of pipelines are very high. Lube oil is usually same as control oil in the old design, and oil exchange is costly due to the volume. And no one in nuclear power is willing to test any technology, and they don't like testing. They like only approved technology, because all the failure issues are closely monitored, reported with authorities and public. So when severe degradation and corrosion need to be clean, there is a certain way how to get rid of the deposits, which is the mechanical force of water jets, which is highly effective to dissolve and remove the deposits, and it's easy to prove. As you see, the state of contamination of the system and presenting here for you was very massive. The system was in the system was oil based on esters due to the decision that it will be safer for the operation, and however the hydrolysis here did very massive pollution of the system during the years. So coming to the technology of hydrodynamic cleaning or hydroblasting, hydrojetting, is that in this operation high pressure water is sprayed on the surfaces, penetrating very well the deposits of soft and hard deposits, especially varnish and degradation products are penetrated. Any kind of sludge, any kind of deposits like corrosion or even welding cinders. How does it look like? The cleaning consists of 4 operations. First is the operation of hydroblasting. So you can imagine on the right corner, this is the rotating nozzle that rotates at high speeds with high pressure water jets that are penetrating the deposits inside the pipeline. This means that these deposits are penetrated with the water stream flushed out from the system. The pipes are cleaned more times than 1, 2 times, 3 times, and the effect of cleaning is checked with visually or by video endoscopy. The pressures we are using are very high, up to 150 megapascal, so 1,500 atmosphere bars for you to recalculate it, and the second operation, which is very crucial, especially for the system of ester-based oil, where the water content should be minimum. It was the biggest concern here from the customer, how to clean it, how to dry it, and to be sure that no remaining water is in the system. So generally it is dried with compressed air with high volumes of compressed and filtered air. At this specific power plant and turbine and system, we used extra dryers, kind of ventilators that were venting the system with dried air. And after drying process, we also inserted in the openings and in the pipes the silica gels to be sure that the humidity will not affect and will not collect in the pipes in between. After cleaning, the system is sprayed with operational oil as a prevention for corrosion, and the openings, the open pipes and openings on the system elements are covered with plastic foil or with special covers. So this is the process of cleaning, where all the pipes are cleaned with this method and with these steps. And I will show you how it looks like in action. On the left corner, you see the rotating nozzle, which is to show you how it looks like. However, in the speed and in the operation, it's in the middle, centralized, and the water jets are penetrating the deposits. It is pushed through the pipe from one end to another, and all the openings um, are with the foil to be able to collect the wastewater. All other components are also cleaned, disassembled, like oil coolers that are washed and cleaned and assembled back for the next step, which is flushing. When I was talking about cleaning result, which is provable for the customer, all the pipeline are later on visibly checked, as well as with help of video endoscopy, and you are seeing the results. So before cleaning, massive corrosion on the left, you see massive corrosion on the top because this is a return line, really massive degradation products in the stream, in the oil stream level, and on the right side, fully cleaned to the raw material, which was the carbon steel. Other pictures, the pictures down, this is not from this power plant, however, to show you fully the size of the effect. You see on the stainless steel before and after how it looks like, what is the effect of hydroblasting. After the cleaning, the inspection is done. As I told you, video endoscopy is used. You see that we are going through the pipes, which is measured, monitored, and also reported to the customer that everything is clean fully. And of course, it's good to have the pictures before, how it looks like, to compare it. And there is a second step of the technology necessary to follow, because cleaning it's good that we penetrated and flushed out most of the deposits. However, something will remain. The flow of the water jet is not high, and it's not perfectly clean. So high velocity oil flush is recommended, which has its parameters. We are using external pumps and filters. We are installing bypasses on important places like bearings, servo valves. When control oil is also included, we are bypassing or installing jumpers on pumps and using our pump, which has high velocities. The filtration is done through absolute fine filters with 3 micron size and with high filtration ratio of beta over 1000. And also, I will show you also on the pictures on several places, important places like bearings and inlet to the bearings, inlet to the servo valves. We are installing special check filters with fine mesh and strong magnet. So how we approach, what are the specifics of our technology, of our flushing, high velocity oil flush, is that we are installing the check filters that I was mentioning. These special check filters are allowing the team to close the line, continue with flushing on other pipeline, and to check the cleanliness at a specific place. It is also allowing us to take the samples at that places and check the cleanliness of the oil and also cleanliness of the magnet. I will show you later some other pictures. Second specification is that all jumpers are equipped with valves, which is allowing us to control the flushing process, allowing us to increase the flow, to reach the high velocities in each and every pipe, and also allowing us to do the thermoshocks, which means we are cooling down the specific lines when closing the bypass and then an opening to flush with hot oil. Full control over the process, allowing us to flush each and every pipe with high velocities. The full flow is monitored with measurements and also reported to the customer. And there are several places where we do the multiple cleanliness control, not only the ISO code or NAS code from the oil tank, however, from many places. This is very effective flushing process with a very short flushing time and extra long cleanliness effect and high machine reliability followed. Our engineers, before going to the project, are preparing for the cleaning process as well as for the flushing process, showing also to the customer how we are installing and where the bypass is, how the lines are being flushed, and this is the pre-engineering before starting the job. It means also a lot of preparation and logistic. If you see the houses prepared for some general project or for the project as I'm presenting here, it is a lot of equipment that we need to ship to the site and also install it on the system. Here you see the real pictures from the turbine, especially on the left. This is from the power plant with this high volume oil system. You see large flushing skid with the pump reaching 20,000 liters per minute of flow. Also I don't know if you can see it, also the high volume filters with 3 microns size, and with this big capacities, the oil is distributed using the hoses to all the places and to the pipings. Not everything is visible on the turbine deck where the bearings are bypassed, but you see also on the right corner, this is from another turbine, however, very good visible what it means to install the jumpers on pumps and to distribute the flow from the flushing skid into the system. On the left down corner, you see extra flushing of the oil cooler, because this is massive, high volume oil cooler that needs to be flushed separately to shorten the flushing time and not to make the flushing longer. We have a special equipment that is flushing the oil cooler in both ways, so we are turning the direction of the flow, which is allowing us to make it shorter and effectively. Other pictures from other projects, you see the scale, what it means to install all the bypasses on the bearings of the turbine. In the middle, you see 200 megawatt turbine, so imagine how it looks like on the 1000 megawatt turbine that I'm presenting here. However, the design was Russian design, and all the pipings are under the turbine, so we have no picture like this to show the scale. As you can see on the left corner, there is this specific check filter where we are taking the samples during the flushing and also checking the filters and the magnets. The construction of the filter, you can see here on the picture on the right. The neodymium magnet is very strong to catch all the debris and all the magnetic particles that are trapped on it. And inside is a specific filter with size of 100 or 75 micron, or whatever size the customer is willing to have, and there we are also checking the cleanliness and the particles present in the system, not only again mentioning underlining not only ISO code from the oil sample. So, and on site we are of course taking the samples. The samples are taken from several places. When I go back a little bit, you see that on each bearing there is a control filter where we can sample the oil and also control the special filter inserts, which is much better and faster, also fastering the flushing process, allowing you to continue with the flushing and control the specific place. Because we can close it, we can take it off, control it, change it, and otherwise flushing on other places is still continuing. So when taking samples from the control filters, they are monitored under the microscope and also with the particle filter, which is showing us the cleanliness code and also the relative humidity of the oil, and showing us what is the water content, to prove to the customer that the system was dried completely. And of course, this is only relative humidity. Also, the final check is that the samples are sent to the laboratory, either to our laboratory or to the laboratory on place, which has the client. And if this is clean, the oil is again removed from the system, drained. The oil tank, oil reservoir is clean because we cannot reach any turbulence in the oil reservoir. Therefore, it is collecting the dirt that was rotating in the system, and this needs to be clean before the final fill in and before the final startup. So I don't know how is the time, but I think I'm at the end. So my summary is that hydroblasting is effective cleaning method for heavily contaminated oil system. So it's much better to clean it than to build a new one. As I mentioned, to build a new one means that you have new pipes that are not cleaned enough and you need to clean them again. This is much more sustainable when we are talking nowadays about sustainability, and this is much more effective. Flushing only, because of course flushing is the standard maintenance process, is not effective for removing severe contamination. Even with our equipment, if we are not cleaning, if you wouldn't clean the system prior to flushing, flushing will take weeks, and with high velocities, all the deposits are removed, circulated in the system. The filter exchange frequency will be high and very costly, and the effect will be low. Presented technology of combined cleaning and flushing is most effective comparing to other methods, mostly recommended for new build oil system, as well as modernized, old and dirty or seized after the failure. Hydroblasting shortens the future flushing process. No flushing oil batch required. It means that if we are cleaning with high pressure water, we have no risk of cross-contamination with old oil when we are, for example, changing for the new one, for different type, different batch, or even different technology from group 1 to 3 to 5. It doesn't matter if this is hydroblasted, we can use whatever oil we want. Trouble-free operation and startup on time. This is very important for the customer. This is proven after several years of operation. These systems are in very good condition. Comparing to the, for example, by the customer where the system is clean and others are not, the difference is high. Outstanding quality from Ecol professionals. I'm within the company since 2005, but Ecol starts in 1991. So we have celebrated 30 years, and over this time we have cleaned and flushed over 800 different oil systems, not only turbines, but oil system from large hydraulics, from engines, from large gearboxes, couplings, and a lot of others. And underlining, we are qualified supplier recognized by turbine OEMs and service companies. There are some mentions like Siemens, GE, Mitsubishi, Hitachi, Rolls-Royce, and more others. So thank you for your presentation. Yeah, I don't know if I can switch to. Do you hear me? I stopped sharing the screen, and I'm ready for the questions. Yeah.
Thank you, Thomas.
If something necessary, I can share the screen again, but I don't have two monitors, so I am not seeing the questions, or I'm not able to communicate with you.
Okay, thank you for your presentation. Interesting. In the audience, if you have any question, you can just send them simply to the chat, inshallah, and we're going to highlight it for Thomas, and he will answer the question. Me personally, I have a question. You mentioned something in the beginning, if I may, about chemical cleaning contaminate the new oil. Can you please elaborate on this, if you don't mind?
Yeah, chemical cleaning. The system used to be cleaned with acids, which is effective method for removing the deposits. However, the acids need to be somehow neutralized. So this is then flushed with water to neutralize the system. However, the pipeline is collected from pieces with seals, with dead zones, and the neutralization process is not always effective, and then the remaining residues, which are not so strong acids, however, there are still some chemicals inside. They are contaminating the new oil, which is very sensitive for any kind of chemicals. So then the result is foaming. It is loss of properties of demulgation. So it is not demulgating water from the oil, and the oil is gone.
So to clean with water is more safer than cleaning with chemicals.
Yeah.
And you mentioned when you clean with water, then you have to dry the pipes, dry it out. So I think is it possible to be 100% dried out, or there is a certain level of water acceptable to be in the pipelines?
Well, it is 100% because the system, the construction of the system is specific, I would say. But on the other hand, if you imagine a turbine having several bearing pedestals, and all the bearing pedestals have the return lines and also delivery line. So, and all these lines are are heading to the collector, which is clean and also dried out. So we are cleaning and also drying from several places. So drying from several places means that there is no space that water can remain. Also, of course, it needs certain time, and maybe good question, and the answer is, if there is a space, for example, there are constructions due to the construction of the building where the pipe is installed and making a dead zone or siphon. So this place we need to discuss in advance with the customer to be sure that we can get with the water out, and which is from time to time necessary to install another flange to be able to disassemble and clean it and dry it separately. Otherwise, the water will remain and it's not able to dry it. But this is during the pre-engineering focused on.
Yeah. Thank you. We have a question from the audience. So we take this question and then after that we can conclude. For what size turbines, say gas, does hydraulic blasting start to become feasible?
Gas turbine is very compact. I understand what is this question for. It is very compact. I don't know what size, because gas turbines, there are very short pipes, and it depends on the diameter. I cannot say this is 15 megawatt or 50 megawatt or 20 megawatt. We are limited with the pipe size and the nozzle. The minimum nozzle we can use is 10 millimeters. Counting with some elbows and with difficult construction of the pipe, we will not get through with the nozzle. However, there are also other ways how to clean these tiny pipes. We can use some solvents. The easiest solvent is acetone, and we can clean it to remove the degradation deposits and then doing the flushing.
Okay, thank you so much for that presentation. It was very interesting. Thank you, all the audience who participated also. Thank you for your support. I hope that was a fruitful presentation, filled with knowledge and expanded your knowledge about turbine oil. Thank you so much, Thomas. And if you would like to add the last word, please go ahead.
Thank you for seeing my presentation. If you have any questions, you can get me on the app, or you have my email, or my presentation will probably send to you, and there is also my contact.
Thank you, everyone. Thank you for joining. And
Thank you.
until next time. Bye.
Yeah, goodbye. Thank you.